So I'm just coming toward the end of my doctorate at Goldsmiths. This is the end of year 4, and I'm going to be talking about a little bit of my research and a few of the things I've been doing sort of as part of that doctorate. My interest is musical cognition in children with specific language impairment. So just to give you an overview, I'm going to start by describing what specific language impairment, or SLI, is, some of the symptoms and theoretical accounts, different causes, and why I think it's important to study music cognition in this group of kids with this particular neurodevelopmental disorder. I'm going to be presenting the findings from 2 experiments that we ran looking at pitch interval, direction discrimination and melody discrimination. And I'm going to finish by talking about what I think these findings from these 2 experimental studies can tell us about SLI and how it can inform our understanding of this developmental disorder. Okay, so specific language impairment. It's a neurodevelopmental disorder and it's diagnosed in children who present with language difficulties without any known neurological cause and who have normal non-verbal abilities. And in practice, the symptom profile of children with SLI is incredibly variable, so they can have a whole range of different language impairments, to the extent that some have really described the term specific language impairment as being an umbrella term to encompass a whole range of different difficulties with language. There are various theoretical accounts of SLI, and some of them have argued that underlying the difficulties with language that we see at a behavioural level, there are very low-level perceptual difficulties for these children. So they have difficulties with very low-level basic discrimination of sounds in speech, and that then has knock-on implications for their language abilities. And there's a whole branch of other theoretical accounts that have argued that underneath the behavioural language impairments, there are a whole range of cognitive difficulties that these children may encounter, so problems with memory or with attention that might impact on their ability to acquire language and to use language functionally. And then there are other theoretical accounts that have argued, again, that there might be some domain general difficulties just learning procedure that might be problematic for children with SLI. But for today, the kind of group of theories that I'm going to focus on are the auditory short-term memory deficit sort of accounts. Okay, and I think the investigation of musical cognition in children with SLI is important because it allows us to begin to, or to continue to consider the extent to which the impairments that we see in children with SLI are really specific to language, or whether they're just symptomatic of some more general difficulties that we should be aware of. And also there's been an explosion of interest in the potential overlap between processing music and processing language. And I don't know, a few of you may remember a few years back a big story hitting the headlines, the Mozart Effect. So listening to Mozart music makes you smarter. So there's these kind of links have been drawn between listening to music and engaging in music and then potential IQ gains and benefits for language processing. And I think that actually that particular Mozart effect has been discredited and there's been a lot of failures to replicate that particular finding that was found in that particular lab. But I think that there's a whole avenue of interesting areas of research there to begin to think about what mechanisms might be involved in processing music that are also used in language. So therefore, what mechanisms could be trained that could improve language functioning for these kids in particular. So that's why I'm interested in music cognition in SLI. Okay, so theoretical background to the studies I'm presenting today. The impaired phonological short-term memory deficit account of SLI. So this frames the difficulties with SLI within a working memory model of short-term memory. So I don't know if you're familiar with this, but within psychology it's been quite an influential model. Information enters short-term memory, and auditory information is stored in the phonological loop component over here, and visual information stored in visual spatial scratchpad. And the hypothesis is that children with SLI have a problem in this particular phonological loop component, and that disrupts their ability to retain auditory information within a short-term memory store. So if you think about processing language, that creates difficulties for online conversation, just processing the language input and retaining that information. And it also poses difficulties accessing long-term stored linguistic knowledge and processing that in an online context for children with SLI. And so this has been tested with 2 tasks that tap the phonological loop component, and I'll come on to those a little bit later on. And it's been consistently shown that children with SLI have problems with both of these measures, so it really does support the idea that there is some problem retaining information in short-term memory, auditory information in short-term memory. And recently Williamson and colleagues, Victoria Williamson and her colleagues, suggested that there were some shared mechanisms involved in maintaining all auditory information in short-term memory. So the phonological loop is important for speech and verbal information, but it's also important for musical information as well. Okay, and some more support for the notion that the phonological loop particularly is important in music. Very recently, Roden and colleagues carried out an intervention study, and they gave 7 to 8-year-olds musical training for 18 months, and they tested their phonological loop before and after the training, and found that after training there were some improvements in the phonological loop component of working memory, which again tends to support the idea that this component's important for both music and language. Okay, so our question was, if the phonological loop is important for processing music and language, and if children with SLI have an impairment in the phonological loop component of working memory, then presumably children with SLI will show up with difficulties on musical tasks that rely on short-term memory processes. So our method, we had 17 children with SLI, and we recruited typically developing control children who were of the same chronological age, and we matched them on an individual basis for gender, chronological age and non-verbal IQ to the children in the SLI group. So the children in the CA group were the same chronological age and had the same non-verbal abilities on a reasoning task. And then we recruited a second group of typically developing children who were younger than the SLI group and matched to that group for their level of language ability. Okay, and you'll notice that there is 1 fewer in the chronological age match group, and that's because I had 1 child who dropped out and didn't want to complete the task. Okay, so we tested the phonological loop with a children's test of non-word repetition. So we presented children with nonsense words, for example, woogalamic, and they were asked to repeat them back to the experimenter. And we also used the digit span subtest of the Wechsler Intelligence Scale for Children, in which children are presented with sequences of digits and asked to repeat them back to the experimenter in forwards order and then again in backwards order. Okay, and this is what we found. So in our children with SLI, you can see there the blue bar here. We found that on the digit span, they performed significantly more poorly than both the chronological age match controls and the younger verbal mental age match controls. So it really does highlight a deficit in the phonological loop. And we found the same thing for the children's test of non-word repetition as well there. So on to music. So we tested musical short-term memory with 2 tasks. In our first experiment, we used a pitch interval direction discrimination. So we presented our participants with 2 tones that made an interval, and we asked them to determine whether the interval was going up or coming down. So I think the sounds were working. They sounded like this. So our intervals varied in size. We had smaller intervals that were between 1 and 4 semitones, and then we had larger intervals that were 5 to 8 semitones. And this is what we found. So as you can see again, the SLI group are in the blue bar, and they did perform more poorly than both the verbal mental age match controls and the chronological age match controls. However, we tested its statistical significance using an ANOVA to compare performance across the groups. And what we found was that actually the SLI children were performing at a similar level to the verbal mental age match controls. So the difference between the SLI group and the chronological age match was significant. They were significantly performing more poorly than the chronological age match controls, but actually they were at a similar level to the verbal mental age. Now if we think about our measures of verbal short-term memory, there's a little bit of a discrepancy there. So actually our children with SLI are performing a little better than we would have expected, given the deficit in phonological short-term memory that we found. And I'll come back to that a little bit later. So our second experiment, we looked at melody discrimination for longer sequences. So we'd looked at pitch interval direction discrimination and found that the children with SLI were performing slightly more poorly than the chronological age match controls, but they were showing better performance than we would have expected given the deficit in phonological short-term memory. And then we looked at their melody discrimination for longer sequences. So we had 3-tone sequences and 5-tone sequences. And it was a very, very simple discrimination task. They were asked to listen to the two melodies and to determine if they were the same or different. And so our melodies were either exactly the same, or they followed the same contour but had a different interval in the middle, or they had completely different contours. And I'll play each of these because you can, this is the different interval one here. Okay, so it's quite tricky to hear the difference there. And same here. Okay. And this is what we found. This is a big graph with lots going on. So, first of all, we found that our typical children, chronological age match, verbal mental age match, control children, and our SLI children showed better discrimination when the melodies had different contour shapes than when they had the same shape but just had a different interval. And you probably noticed yourself when you heard the melodies, it's easier to discriminate the changing contour shape when you hear it, and that's certainly what we found in all of our groups. We also found, again, the SLI group was showing poorer performance than both our chronological age match controls and our verbal mental age match controls overall on this task, which is consistent with the idea that the phonological loop is impaired and they can't retain the melodies in short-term memory in order to make the discrimination. And we also found in our typical children, but not our children with SLI, that they found discrimination of longer melodies harder than discrimination of shorter melodies, which again points to the idea that the phonological loops involved in retaining those information, that retaining those melodies within short-term memory, for typically developing children at least. The most interesting thing that we found was that actually the children with SLI were showing a different pattern of performance overall on this task. So you give them these melodies to listen to and to discriminate between, and the SLI children are doing something different to our typical kids. So you can see that the blue bars, we have our different interval condition and we have our different contour condition. And actually the children with SLI are showing same level of discrimination accuracy for 3 and 5 tones, different interval, and 3 and 5 tone different contour. Whereas our typical controls, as you can see, they show slightly better discrimination of 3 tones than 5 tones each time. So there seems to be something qualitatively different going on in our SLI group when we give them this task to do. Then we looked at correlations. So if the same bit of memory is involved in processing digit span and children's test of non-word repetition and also the melodies, then we would expect that there would be positive correlations across these two measures. If it's the same, if it's loading on the same component in working memory, then we would expect those kids that have good phonological working memory to do well on the children's test of non-word repetition and the digit span, but also to perform well on the melody discrimination task. And in our typically developing children, that's exactly what we found. We found nice strong correlations between certainly performance on the digit span and performance on the melody discrimination task. But in our children with SLI, we didn't. So again, there appears to be something different going on in the children with SLI as compared to our typical kids. So overall, we found that children with SLI show impaired digit span and non-word repetition relative to chronological age and verbal mental age match controls. We also found that the SLI children showed poorer pitch interval discrimination in the chronological age match, but at a similar level to younger children who had the same verbal mental age. And we found that the SLI kids had poorer melody discrimination overall than both our chronological age and verbal mental age matched kids. And then in the correlational analyses, we found that typically developing children showed relationship between musical and verbal short-term memory measures, but the children with SLI didn't. So what do we think it means? Well, to go back to our model, the hypothesis was that children with SLI have an impairment in the phonological loop component, and this then has knock-on implications for their processing of both language and music. And in our typical controls, this is what we found. Our correlations seem to show that the same bit of memory is involved in processing both the verbal information and the musical information. But our children with SLI didn't show that. And so what we're thinking of is, well, why? What are they doing differently? When you give them those melodies to listen to and to discriminate between, why are we not seeing the same correlation in our children with SLI? And the suggestion is that perhaps our children with SLI are doing something different. So you ask them to discriminate between the melodies, and perhaps they're not processing the melodies in the same way. Perhaps an impairment in the phonological loop has meant that children with SLI have had to develop different compensatory strategies to process auditory information, which leads to different performance on a measure that taps phonological loop and doesn't allow roots to compensation versus a measure that allows for roots to compensation. Okay, so which compensatory strategies do I think may be being used? Well, from the speech processing literature, there's evidence to suggest that younger children and older children and adults listen for different auditory cues. So younger children will listen for the most informative and distinctive cues in a stream of speech in order to be able to process that information, rather than representing all of that information in memory. And perhaps our children with SLI are doing something similar. Perhaps they're persisting with a similar processing strategy. Alternatively, one of the interesting things that we found across both of the tasks, if we think about the pitch interval discrimination task again, our children with SLI were performing better than we would have predicted given their deficit in phonological short-term memory. So perhaps there's another route to representing music in memory that doesn't exclusively rely upon the phonological loop. So for example, perhaps children with SLI are able to represent the contour shape in music by relying on a different component of memory. So perhaps the visual spatial sketchpad could be involved in representing music as well as the phonological loop component. So future work. We know very little about this relationship between phonological loop and musical processing in typically developing children, and I think that needs more work. As phonological loop increases over age, as memory develops, how does that then impact on musical processing in typically developing children? But also begin to explore the idea that perhaps music can be represented by different components within short-term memory. So perhaps as well as representing music as auditory information, you can also represent the shapes of music or the colours of music. And there's some really interesting work going on looking at synesthesia in music, people who listen to music and see colour and shapes. And so to think about the extent to which visuospatial memory could also be involved in processing music. And finally, an intervention study. It would be great to see the findings from Rodin et al. Replicated. It would be great to see whether or not musical training does lead to improvements in the phonological loop component of working memory in typically developing children, and whether or not the same model could be adapted and applied for children with SLI to try to improve phonological working memory for these kids. And that's it. I'd just like to thank my collaborators, Professor Pamela Heaton and Dr. Victoria Williamson, and all of the staff and pupils in the schools who took part in the research. Thank you. Yes.
When you were selecting your subject pools originally, the two groups, did you also look for the variable of multilinguistic and musical background? Because obviously lots of studies with music in young children have made them very aware of pitch. You can get perfect pitch in Japan, etc. And people who tend to be good at music tend to be good at languages as well.
Absolutely.
I did some work on that when I was doing psychology.
Yes, absolutely. There is some really interesting work looking at early musical training and its effect on absolute pitch. So yeah, we did a musical background questionnaire, and it was quite shocking actually. I was quite surprised. None of the children had any formal musical training. So our SLI group ranged from 7 to 11 years. None of those children had been involved in any formal musical training, and actually a number of them had been taken out of class music sessions to have their additional language maths catch-up classes in the resources. And then in the typically developing group, again in our older group, none of the children played a musical instrument or had any music lessons, although there were a couple of them that had parents. So there is a little bit of variability there.
Sometimes there's music made at home, even though formal lessons aren't there.
Exactly. And so in our older typically developing controls, I think there were 2 children who had come from musical parents, and so it would be certainly interesting to see the extent to which that early musical environment could impact on music and language.
And languages as well, ones who have tried?
Yes, yeah, so they were all first English language speakers. Yeah, we controlled for that. No, that's, yeah, that was one of the things that we controlled for.
Amy, was this, I know the study was carried out on children, and you mentioned that the SLI group were from 7 to 11. Would that sort of, do you think that would transfer across to adults as well, or is it just something that we haven't touched upon?
Well, interestingly, this impairment in non-word repetition, which is, you know, the mark, it's a classic kind of clinical marker of SLI. It's the one thing that persists right through into adolescence, and actually it's found in relatives who haven't met the threshold to be diagnosed with SLI, but these difficulties with phonological short-term memory have been identified in first-degree relatives. So it does seem to be quite a pervasive, and it seems to have a heritable component and seems to be quite pervasive and create problems right the way through. Yeah.
Because it does kind of lap over into dyslexia and all that.
Absolutely, and a number of children who are picked up with speech and language difficulties at 5, 6, 7, even though the expressive language problems might remediate over time and with intervention, actually a number of them do go on to have literacy problems and difficulties with dyslexia and things as well.
Phonology and the phonological deficit does kind of carry through, and that is part of that thing.
Yeah, absolutely.
Has this been tested in a twin study?
Yes, Dorothy Bishop did a twin study looking at environment versus heritability as contributing factors to SLI, and found that a lot of the auditory processing difficulties that had been identified were largely environmentally mediated, whereas the difficulties with phonological working memory appeared to be heritable. So those two factors seem to interact to give, push children over a threshold into a diagnosis of SLI. But,
From counselling or clinical perspective, how do you apply this? For example, a child in therapy that has a condition as this, how, with the result you found, how do we translate that to therapy?
Well, personally, I'd love to see an intervention study. I'd love to know if musical training, if giving kids formal musical training, musical instruction, leads to any improvements in cognitive processing in a tightly controlled study. So I'd like to try to see if we could replicate the findings of Rodin that have just come out with 7 and 8-year-olds, and there's some really interesting work being carried out over in North America at the moment, looking at musical training programs and the use of musical training and whether or not that does have any positive effects on cognitive ability. Problem is we don't have that experimental evidence to support any interventions yet. I think that's the first step. If we can get some clean, good, replicated experimental evidence to support the idea that music training could improve phonological working memory, then obviously in practice we could be encouraging the kids with SLI to go to the music lessons rather than come out of them to have their the extra catch-up lessons.
Because that's what I was thinking. If the research is showing that, but the children that are part of the research have been taken out from the music, how does that then impact clinicians, counselors and therapists who will be seeing these children for different reasons? How is the project going to help?
Yeah, and I think we're a long way from actually getting to a point of implementing any change. I think what needs to be done now is more experimental work to try to find out if these things that we're seeing and these ideas that we have, if they're valid, before we spend a lot of time and effort in actually rolling out music training programs.
Is it specifically music, or would it be things like rhythm and rhymes, like nursery rhymes? Or is it specifically pitch and tone and
Well, there's some really interesting work at the moment being carried out looking at the relationship between pitch and rhythm and phonology, and whether or not training, the use of nursery rhymes and rhythmic sequences can actually sharpen up discrimination of phonemes in speech. And yeah, there's certainly some evidence to suggest that from an auditory processing point of view, the kind of engagement with rhythm classes and rhythmic instruction can sharpen up that phoneme discrimination. But I'm not really sure. I think one of the advantages of music training is that it's interesting and it's engaging and it's fun, in theory. And so children who are involved in learning musical instruments are more engaged and more. And I think part of the benefit that we are seeing in things like attention and memory come from the fact that children who are engaged in music training are enjoying it, and so I think that might be part of the mechanism that's leading to these improvements.
To the very, very end, my apologies for dipping in and out, but we had some good staffing progress today. And I look forward to getting into some more serious discussions about the issues that were raised earlier. So it's open door. If you have some questions, you have some comments, come in, meet with me, meet with Dave. We're going to move forward on these issues, and we're going to do it as a good team. Thank you all very much.
Thank you.